Number 11. Which expression is equivalent to m to the fourth, q to the fourth, z to the negative 1 times mq to the fifth z cubed, where m, q, and z are positive? Even though there are parentheses separating these, they're not really separate. This isn't a case of addition or subtraction, things where it kind of matters that they're separated by parentheses. This is just multiplication. And each of these terms is just multiplication. Each of these, these terms that we have, these variables together. So m to the fourth, q to the fourth, z to the negative 1 is the same as m to the fourth times q to the fourth times z to the negative 1. And the parentheses is another way of saying times in between. So all that is times m times q to the fifth times z cubed. And there's nothing in here. There's no negative saying all of this is negative or nothing like that that means we can't just write it like this and then reorder them. It really is just combining like terms, multiplying the like terms by each other. So we're going to look for the things that have the same base. So I have two terms that are base m. I have two terms that are base q. And I have two that are base z. And I want to multiply each of those individually. When you are multiplying exponents, or let me restart that sentence. That one got away from me. When you are multiplying two terms together that have exponents in them, if they have the same base, you add the exponents. Let me show you this with real numbers. So if I had 2 squared times 2 cubed, I am going to add those exponents. I keep the same base. I add the exponents, and I get my answer. So 2 squared times 2 cubed is 2 times 2 to the power of 2 plus 3, or 2 to the power of 5. Here is the reason why this works. When we say 2 squared, we're saying 2 times 2. When I say 2 cubed, I'm saying 2 times 2 times 2. Well, how many times am I multiplying 2 together now? 2 times, then 3 more times. 2 plus 3, those are 5 2s. This is why it works. It's just counting them up. The same thing works when we change the base to a variable. It does not matter. So if I change this and say m squared times m cubed equals m to the power of 2 plus 3 equals m to the power of 5. Same difference. The only sort of thing to be wary of is when you do not see an exponent there. There's still an m here, right? There is one m. There is a single m. So there is an invisible, but I promise it's there, 1. Do not forget that. Because m to the fourth times m is not just m to the fourth. There's an m there. There's 5 m's now. I had 4 m's here. I have 1 more m. I've got 5 m's total. So that's an invisible 1. Do not forget the invisible 1. Okay, so let's just combine all these and we'll have our answer. We just need to do some addition. M to the fourth times m to the first. 4 plus 1 is 5. Q to the fourth times q to the fifth. 4 plus 5 is 9. At which point you should already know your answer because there's only one actually that has m to the fifth. And then that one also has q to the ninth, and there's no other one that has q to the ninth. But we want to be absolutely sure that we haven't just made a mistake, so we keep going. Z to the negative 1 times z cubed. Even though it's a negative, same rules apply. You just add them together. Negative 1 plus 3 is 2z squared. So m to the fifth, q to the ninth, z squared, and that's b. And yeah, as soon as you did m to the fifth, you would know it was b, like I said, because no other answer has m to the fifth. I still think it's a good idea to at least do the second one also. Maybe after you get 2 of them, you're like, okay, I know it's b. But at least 2, and that's a good way of catching careless errors or accidental oversights, where you read a number wrong. Because let's say I got m to the fifth, q to, maybe I got q to the 8th. Then I go, wait a minute, there's no m to the 5th, q to the 8th anywhere. I did something wrong. So it's good for catching things like that. So I'd go at least to q, maybe not to z. Yeah, and if you're wondering why z to the negative 1, any exponent that's negative means 1 over that. So 1 over z to the power of 1. If this was z to the power of negative 2, z to the power of negative 2, that's the same as 1 over z to the power of 2. So the reason why u still works, that we say negative 1 plus 3. If we were to write this, it would be z to the power of negative 1, which is 1 over z to the power of 1, times z cubed, which is z times z times z. And since these are fractions, we would put this over 1 so we could multiply them. And then when you multiply this together, you get z times z on top, all over z on the bottom. If you learn about canceling out in fractions, you would go, oh, I can cancel those. And what are you left with? Z squared, baby. So there's your z squared. I digress. I know that that's a little more information you probably were looking for, but if there's anyone out there that was wondering, wait, negative 1, I don't remember that. I want you to have that information and not have to go looking elsewhere if you wanted it, because that will show up in other things. But our final answer there, m to the 5th, q to the 9th, z squared, b is my answer. Hey guys, this video was helpful or useful in any way, please feel free to let the algorithm know about it. Like, share, comment, subscribe, even buy me a coffee if you're so inclined. Links for that down below as well. Thank you so much for stopping by. I hope you have a great day. See you later. Bye.